Hi everyone, Blake back again to present the pertinent topics that you'll need to know in order to ace the research section of your exam. Previously in the series, we've discussed what studies can do and how to set them up. Now we have data from those studies and we need to interpret and see how it fits into the purpose of the study. The analytic tools that we'll discuss will tell us if the observed results and trends are significant and meaningful, guiding us to make implications for further research questions or projects. The first topic that we'll be covering in this video is inferential statistics. Inferential statistics describes the process in which we use statistical analysis to infer properties of a larger population from a smaller observed data set. Inferential statistics helps researchers determine if the results are meaningful, significant, and suggestive. Inferential statistics is also used for hypothesis testing, a concept that we'll cover in this video. So, with that being said, there are several approaches for statistical analysis, and the one you will choose will depend on what you want to know, what type of data you have, the method of data collection, and how much time and resources you have available. Now, the first step of any research process is to determine the null and alternative hypothesis. A null hypothesis predicts that there is no statistical significance between the variables being studied. In other words, it suggests that any observed difference or effect is due to sampling error or variation. In the bell curve below, any result in the shaded area fails to reject H0, which represents the null hypothesis. Meanwhile, the alternative hypothesis predicts that there is a statistical significance between the variables being studied. In other words, it suggests that the observed difference or effect is not due to sampling error or variation, but that there is a genuine relationship or effect. In the bell curve below, any result in the shaded area rejects H0, which represents the alternative hypothesis. To help make sense of this, imagine that you're conducting an experiment to determine if vaping leads to the development of caries. Your null hypothesis would be that there is no difference in the incidence of caries between those who vape and those who don't. If we disprove this null hypothesis, then we get the alternative hypothesis, which would suggest that the incidence of caries is not the same between those who vape and those who don't. Remember that when we reject the null hypothesis in favor of the alternative hypothesis, we're saying that there is a meaningful effect or relationship between the studied variables. Finally, we have to determine if our statistical method will need to be inferential or descriptive. Inferential statistics help us make judgments and predict what might happen in the future, or to extrapolate from a sample we're studying to the whole population. As mentioned previously in this video, inferential statistics are used to test a null hypothesis. Descriptive statistics, on the other hand, shed light on how the data is distributed across a population of interest, giving us details like variance within a group and mean values for measurements. Now, when we discuss descriptive statistics, there are three main components you should know. The first are the measures of central tendency, then we have measures of variability, and then the distribution type. Let's begin by discussing the measures of central tendency. There are three measures of central tendency you must know for your exam. The first is the mean, which is the arithmetic average of the dataset. It's calculated by taking the sum divided by the number of observations or data points. The median is the middle value in the dataset when the dataset is arranged in ascending or descending order. And finally, the mode is the most frequent value in the dataset. It's worth noting that sometimes there can be more than one mode in a dataset. Next, we'll move on to discussing measures of variability. The first measure of variability that we'll be discussing is variance. Variance is a measurement of the spread between numbers in a dataset, and it's calculated by using a formula that's not too important on the exam, so we won't bother covering it. We can think of the standard deviation as the average distance between each data point from the mean value. It's important to know that the standard deviation is the square root of the variance. The smaller the standard deviation, the closer the average data point is to the mean value. The greater the standard deviation, the farther away the average data point is to the mean value. And don't worry, percentiles and quartiles will be discussed soon. Now we're ready to apply some of our knowledge. Now let's say we have a normal distribution, which is sometimes called a bell-shaped curve. The normal distribution is a pattern of data that fits many naturally occurring scenarios, such as the height and weight of adult humans. We can write down our measures of central tendency, which include the mean, median, and mode. As seen in our diagram, the distance between each dotted line represents one standard deviation. The important thing for you to know is that 68% of data lies within one standard deviation of the mean. This means that, for example, 68% of humans will have a height that will lie within one standard deviation above or below the mean height of adult humans. 95% of data lies within two standard deviations of the mean. This implies that 95% of adult humans will have a height that lies within two standard deviations above or below the mean height of adult humans. And finally, 99.7% of data lies within 3 standard deviations of the mean. Another key takeaway from this concept is that the larger the sample size, the more accurate the sample mean and sample standard deviation will be to the actual population mean and standard deviation. This is because increasing the sample size decreases random error. And finally, let's discuss the 3 different types of distributions. The symmetrical distribution follows a normal distribution curve. In a symmetrical distribution, we can see that the mean, median, and mode are all in the center. Symmetrical distributions are a result of the mean, median, and mode all being equivalent to one another. The positive skewed distribution is a non-normal distribution. Positively skewed distributions can be visualized when the tail on the right side of the distribution is longer than the left side. The mean is found at the very right because the average value is pulled upwards. Meanwhile, the mode is found at the very left because the most frequent value is skewed down. This can happen when there are very few large values or outliers within a dataset that pull the mean to the right of the median and mode. The negative skewed distribution is also a non-normal distribution. A negatively skewed distribution can be visualized when the tail on the left side of the distribution is longer than the right side. The mean is found at the very left because the average value is pulled downwards. Meanwhile, the mode is found at the very right because the most frequent value is skewed up. A negative skew can happen when there are very few small values or outliers within a dataset that pulls the mean to the left of the median and mode. If it gets confusing to know which one is positive skewed and which one is negative skewed, just imagine a ski jumper on the distribution curve. The ski jumper will ski towards the positive values in a positive skewed distribution and will ski towards negative values in a negative skewed distribution. This brings us to the next concept for this video, which is the p-value. The p-value is the probability of observing results as extreme as the ones we actually observed, assuming that the null hypothesis is true. Usually, if p is less than 0.05, we reject the null hypothesis, indicating statistical significance. Now I know this sounds complicated, so let's take a step back. Let's offer a really simple example to make this more straightforward. Imagine you're trying to figure out if having good oral hygiene makes people happier. You compare one group of people who are really stringent adherents of oral hygiene and another group of people who don't prioritize oral hygiene as the control group. Now we begin by assuming that the null hypothesis is true. Basically, we assume that good oral hygiene does not make people happier. Now let's go ahead and graph out our results and all of the data. On the x-axis is the set of possible results, and the y-axis is the probability density. As you should know by this point, the data in the middle are more likely of an observation than the ones at the very top and very bottom, which are very unlikely observations. Let's say we're interested in this observed data point. The p-value is the probability of obtaining this observed result or more extreme results, which is shown in this blue shaded region. If the p-value is low, typically below 0.05, it suggests that the difference in happiness between the good oral hygiene group and the control group is not just due to chance. In other words, a low p-value indicates that there's something going on. Maybe good oral hygiene does make people happier. So, if your p-value is low, once again, usually below 0.05, you might say, hey, there's a good chance that having good oral hygiene is causing the happiness difference in my groups. But if it's high or above 0.05, you might think, the difference could just be random chance. Maybe oral hygiene doesn't really affect happiness. So in summary, a low p-value suggests that your results are meaningful and not just due to luck. In other words, your results are statistically significant. But keep in mind, although the threshold is usually 0.05, this is not always the case. It just depends on the study. On your exam, you will not be expected to calculate a p-value like you might in a statistics course, but it is important that you be able to interpret what it means. So now that we know what constitutes results as statistically significant, I need to have a serious discussion with you. Just because statistical significance tells us the probability that an observed result is not due to random chance, this does not imply that we should go ahead and just start treating patients with our new drug or device. Instead, we need to consider clinical significance, which focuses on whether results have practical importance or relevance in the real world. For instance, a new medication may demonstrate a statistically significant reduction in blood pressure compared to a placebo. However, if the reduction is so small that it doesn't translate into any meaningful improvement in patients' health or quality of life, the clinical significance of the finding may be questioned. In summary, statistical significance doesn't necessarily mean clinical significance. As usual, let's take the information that we've learned from today's video and use it to answer some practice questions. This question asks, in a study with normal distribution, The average number of bleeding on probing sites on patients was 33 with a standard deviation of 5. If the study had 100 participants, how many participants fell within the range of 28 to 38 BOP sites? We have option A, 25 patients, B, 34 patients, C, 68 patients, D, 95 patients, and E, 99 patients. Now, in order to answer this question, we need to remember that 68% of data lies within one standard deviation of the mean, 95% of data lies within 2 standard deviations of the mean, and 99.7% of data lies within 3 standard deviations of the mean. Now, the correct answer for this question is option C, 68 patients. So in this example, the mean is 33 and the standard deviation is 5. One standard deviation from the mean in each direction is 28 to 38 and holds 68% of the patients. Since there were 100 participants in this study and 68% of 100 is 68, 68 participants fall within this range. Therefore, option C is the correct answer. Next up, we have question 2. Which of the following best describes the purpose of p-value? We have option A, it represents the probability of rejecting the null hypothesis. B, it measures the probability of making a type 2 error. C, it is determined by calculating the standard deviation. And D, it represents the probability of obtaining an observed outcome, or one more extreme, assuming that the null hypothesis is true. And the correct answer for this question is option D. It represents the probability of obtaining an observed outcome, or one more extreme, assuming that the null hypothesis is true. So remember that the p-value guides researchers on whether or not the null hypothesis should be rejected. If the null hypothesis is rejected, it implies that the results are statistically significant. And last, we have question number 3. A group of researchers compared the effectiveness of traditional brushing and using a new electric toothbrush in reducing plaque buildup. Based on the results of the study, the researchers found that the electric toothbrush was more effective with a statistical p-value of 0.15. Which of the following statements is true? We have option A, p is greater than 0.05, so the null hypothesis is not rejected, it is statistically significant. B, p is less than 0.5, so the null hypothesis is rejected, it is not statistically significant. C, p is greater than 0.05, so the null hypothesis is not rejected, it is not statistically significant. And D, p is less than 0.5, so the null hypothesis is rejected, it is statistically significant. And the correct answer for this question is option C, p is greater than 0.05, so the null hypothesis is not rejected, it is not statistically significant. So remember that typically, if the p-value is greater than 0.05, we fail to reject the null hypothesis and conclude that the results are not statistically significant. So in summary, we learned about the importance of statistical analysis, we learned the difference between the null and alternative hypothesis, we learned about the difference between inferential and descriptive statistics, and we learned about different types of statistical analysis. I really hope this video helps, and I'll see you in the next one.